Hey everyone! Today we're diving into clustering algorithms. Clustering is all about grouping similar data points together without any labels to guide us. It's a type of unsupervised learning where the algorithm discovers hidden patterns on its own. Think of it like organizing your messy closet by color and type without anyone telling you how to do it. These algorithms power everything from customer segmentation to recommendation systems, and today we're focusing on the two most popular approaches, K-means and hierarchical clustering. Let's walk through how K-means actually work step by step. First, you start with your input data and choose how many clusters you want, that's your K value. Then the algorithm randomly places K centroids, which are basically the center points of your clusters. Next, every data point gets assigned to its nearest centroid using distance calculations. After that, the centroids move to the mean position of all points in their cluster. Here's the clever part, this process repeats over and over, reassigning points and recalculating centroids, until the centroids stop moving. That's when you've reached convergence and have your final clusters. So what makes K-means tick? The algorithm has one main goal: minimize the sum of squared distances between points and their cluster centroids. It typically uses Euclidean distance, which is just the straight line distance between 2 points. The beauty of K-means is that it's fast and works great even with massive datasets. But here's the catch, you need to decide how many clusters to use up front. That's where the elbow method comes in. You run K-means with different K values, plot the error for each, and look for the elbow or bend in the graph. That bend tells you the optimal number of clusters. Let me show you how simple K-means is in Python. We import K-means from scikit-learn and create some sample data points. Notice we have two clear groups, points near the origin and points near 8,8. We create a K-means model with two clusters, fit it to our data, and boom, the labels show us which cluster each point belongs to. 0, 0, 0 for the first group, 1, 1 for the second group. To find the optimal K, we loop through different cluster numbers, track the inertia which is the sum of squared distances, and then plot it to find that elbow point. Super straightforward. Now let's talk about hierarchical clustering, which takes a completely different approach. The most common type is agglomerative, which works bottom-up. Imagine starting with every single point as its own tiny cluster. Then you repeatedly merge the two closest clusters together, step by step, until everything forms one big cluster. The cool thing is you don't need to choose K up front. Instead, you visualize the process with a dendrogram, which is like a family tree of your clusters. You can cut this tree at any height to get however many clusters you want. It's more flexible than K-means but slower, especially with large datasets. So to wrap it all up, K-means is your go-to when you need speed and scalability, especially with big datasets. Just remember you need to pick K first, and the elbow method is your friend there. Hierarchical clustering shines when you want flexibility and don't know how many clusters you need up front. The dendrogram gives you that awesome tree visualization. Both algorithms power incredible real-world applications from customer segmentation to recommendation systems and even image compression. Now you've got two powerful unsupervised learning tools in your machine learning toolkit. Go experiment with them on your own datasets and see what patterns you can discover. That's a wrap on this one. If this video helped you understand the concept, please hit that like button, it really helps the channel grow. Subscribe so you never miss a new video, and drop your questions in the comments below. Share this with a friend who's learning, and I'll see you in the next one.